Let's talk symmetry. You probably think you know it, but there's way more to it than meets the eye.
I love this quote. Immunity to change. It's a whole new way to think about what symmetry actually is.
So basically, it just means you can do something to an object and it looks exactly the same afterward.
Okay, so what are these moves? Let's break down the three basic types of symmetry.
First up is reflectional symmetry. You know, the classic mirror image stuff we all learned about.
And you see it everywhere, right? From a butterfly's wings to the letter T, it's all the same principle.
Next, we've got rotational symmetry. This one's all about turning something and it still looks unchanged.
What's cool is it can be just a few turns, like a triskelion, or infinite, like a perfect circle.
And the last basic move, that's translational symmetry. It isn't about flipping or turning, it's about sliding.
Yeah, just think of footprints in the sand. You shift the whole pattern over and it's the same thing. Simple. Okay, those are the basics. But what happens when you mix and match them? This is where it gets really interesting. First up is glide reflection. It's a combo move. A reflection followed by a slide along that same line.
So you flip it, then you slide it. That two-step process creates this really cool offset repeating pattern.
Another combo is helical symmetry. Just think of a screws thread. It's a twist and a slide combined.
And this is huge. You see it in a simple spring, and you see it in the very code of life, our DNA.
But wait, does symmetry always have to be about keeping the same size? Let's mess with that idea.
This brings us to scale symmetry, or self-similarity, a pretty wild concept actually.
The perfect example of this? Fractals. You can zoom in forever, and the pattern just keeps repeating itself. You find this hidden order in things that look totally chaotic, like a coastline or even a bolt of lightning.
All right, let's get to the biggest idea of all. This one changes everything about geometry itself.
This quote from Felix Klein gets right to the heart of it. It's a huge, game-changing idea from the 19th century.
Get this. Symmetry isn't just in geometry. It's the actual rule book that defines the geometry.
So if symmetry writes the rules, what happens when you break them? Well, that question is at the very heart of modern physics.